All right, so here is the situation. We'll load up this. This is like this. Okay, let's go and do laptops closed, screens off, laptops closed, screens off, screens off. Here we go. All right, so before we get started, the first set of grades are in, and they're in yesterday or end of wherever. And the deadline for resubmission is next Wednesday at 2:30. And if you do need to resubmit, use the form. Those of you who were not in my class last semester will be new to this. Okay, so check your grade for, those assignments. And if you have something other than a 9 or 10, because if you got a 9, you can't get it to a 10 because you'd be submitting 100% at 10% reduction. So if you have something, a grade below a 9, you can complete it first, then complete the form to let me know that you've done some work and I should grade it. Okay. If you don't submit the form, I'm not going to check your work, and the deadline is the deadline. Okay. These assignments, the last one we finished was on Monday. If you were absent, well, you had plenty of time to do it. Okay. I graded it, and you need to get it done before the deadline. I'm not going to talk about the assignment after the deadline. Don't come to me the day, I had tech issues the day before the deadline, or, I was sick the day before the deadline. No. The assignment was done back here. It was due back here. You had a couple days to wrap it up for on time. You didn't, or you did. But if you didn't, you have another week to get some points. After that, I'm not going to discuss that assignment or those assignments. Okay, so we're moving on with lesson 5 and 6 of the current unit. Oh, wait, you guys can't see. Oh, that's funny. All right, let's try again. Yeah, that doesn't happen very much. Stay co-host, and we'll go like this. And now for the people who are present, not just the people watching the replay. Okay, so the deadline, I'm not going to say everything again, but everything was graded yesterday. And so you have until Wednesday to get it done. Okay, and the form is right there. You need to submit the form so that I know that you did something. I don't get a notification that you changed anything in your account. Okay. A lot of people miss points for the lesson 4 reminder app because they didn't do all the extra things that I pointed out, which is strange. Okay. Even though everywhere that I mentioned it, I made a point that people shouldn't be willfully ignorant, and some people still manage to be willfully ignorant. Okay. And all right, so we're going to start with the new sort of chapter within the unit, which is going to be a refresher for several people because it's about loops. Okay. We have introduced lists, great way of keeping track of lots of things that are similar. Now we're going to do some recap for loops, doing something, writing code that can do the same thing over and over again, with the key being the goal is traversals. If you loop through a list, it is a traversal. We are going to eventually use loops to, magnify the possibilities of lists. But before then, we need to do some loop stuff. Okay, so lesson 5 and 6 is going to be our goal for today. It's going to be pretty light lifting overall. And we're going to start with a code.org video that if you were here in my class on a particular day, on the day we saw it, it might be familiar, but if not, I think it was in the digital scene unit. So if your class didn't do the digital scene unit, you may not have seen it. But because if you're working from a Chromebook, you can't get to all the YouTube stuff, I've put it in here. This is not the lesson 5 and 6 replay. That's what we're doing right now. But this is the video that we are about to watch in class for those of you following along at home. Okay, so how does this work? Let's go like this. And we'll watch this, and then we will jump right in.
My name is Jerome Holman, and I work in the Windows Devices group at Microsoft. It's basically a team where we build cool stuff, tablets, phones, things like HoloLens that hopefully will excite and delight customers. Computers are not infinitely fast. They are much faster than human beings at many tasks. In 2014, the fastest computer in the world was clocked in at an astounding 33 quadrillion calculations per second. Now, for some tasks like composing a song, we generally think human beings still do a better job. For highly repetitive tasks that can be automated, computers are much, much better. Programming languages usually have a few different ways to define and control behavior that should repeat. These are usually called loops. They go by different names in different languages like for loop, while loop, do while loop, for each loop, repeat loop, and so on and so forth. These types of loops have small differences, but all of them are just different ways to get the computer to execute some lines of code repeatedly. The generic term for looping is iteration. Iteration is just a fancy word that means repeat. It usually is in reference to the repetition of a process or procedure. This is why iteration is a good generic term. Often in programming, we have an algorithm that just needs to repeat a specific number of times, or repeated while some condition holds true. We're going to show you how to use a looping structure called a for loop in JavaScript. You can find for loops in the control section of the toolbox. It looks like this when you drag it out.
Doesn't quite.
A for loop in JavaScript, like this one, is just a type of counter loop. It counts up from 0 to the number you type in. Why does this simple for loop look so complicated? JavaScript, unlike some languages, doesn't provide a simple repeat loop structure. The for loop is a very powerful and versatile looping structure for both advanced and simple tasks. We're just keeping it simple for now. Let's do a little experimentation. You can drag any commands you like inside the for loop block. These commands will be executed over and over for however many times you specify in the loop. When you run the loop, notice the AppLab highlights each line as it executes. Now, why does the for loop block highlight after each iteration of the loop? That's because the for loop needs to check its counter every time to see if it should stop or run the commands inside the loop one more time. Well, that's not terribly exciting, but it's because we're not really using the computing power that looping gives us. Instead of looping this piece of code 4 times, let's loop it, 200 times and see what happens. Now that's more interesting. One thing to note about loops is that your code will still execute from top to bottom as before. You can put lines of code before the loop if you need to get something set up before the loop starts. Likewise, after the loop is done executing, it will pick up on the line right after the loop. For example, if you want to move the turtle before drawing this figure, I could use a move to command before the loop. And if I want to draw a red dot to see where the turtle ends up, I could add lines after the loop. You will use the same top-down design in many of your projects. These problem-solving techniques will help you identify where loops belong in your code. You still might want to write a function to do a small part of your program. and then write a loop to call that function. Take, for example, the problem of trying to draw this. You might recognize that this is just a bunch of squares, each one rotated slightly before being drawn. Previously, we would have had to make a function to draw a square. To get the 10 rotating squares, we would have had to call this function 10 times, turning a little each time after we called the function. This would have involved a lot of copying and pasting. This code works, it does, but it's very repetitive. Let's just see if we can simplify our code with a loop. We already have a working function that does a piece of the problem once. We can easily stick the function call into a loop to do it multiple times. Clarity and readability are important considerations when programming. As we can see, this code is now much more readable. It's obvious just from looking at the loop that the intent is to draw a square a bunch of times. Loops are a powerful programming construct that uses the computer's primary advantage over humans, that being their amazing speed. By repeating commands as many times as we wish, loops allow us to solve new problems at a scale that would be impossible without computers. There is still much to learn about the loop, but the concept is simple. Loops repeat commands as many times as we need. Now you know how to use a simple loop. You can use them in your programs and take advantage of your computer's power and speed.
All right, go ahead and log in, and I think I opened it up. The lesson. Yeah, lesson 5 from current units. The only deliverable for this is a check for understanding. And the check for understanding is about comparing loops and functions. Okay, when breaking a problem down, you often encounter elements that you want to use repeatedly in your code. Sometimes it's appropriate to write a new function. Other times it's appropriate to write a loop. There's no hard and fast rule to which is better, but what do you think? What kind of circumstances would lead you to write a function versus writing a loop? Okay, I don't need a huge BCR, just a couple of sentences, like one for loops and one for functions. Like, what are the situations that those are good, even though they both do repeat? All right, I'll give you another 30 seconds and we'll get going. All right, let's go ahead and, do I unlock it? No. All right, go ahead and refresh and go to lesson 6. And we will investigate some loops. And there will be extra add-ons other than what is just there. So if you think you're going to fly through and just do like the modify one pointless thing, that ain't it. Okay, so stick with us. All right, bubbles 1 and 2 are the same, and I don't really understand the point of the bubble 1. Maybe just to look at the app before we get into how it works, we can look at what it does. It takes single user input. That's going to be a number value for the number of times to flip a coin and have some sort of output that it is apparently picking heads or tails at random and providing a count for how many of each you get. And there you go. That's what it does. Let's go on, go to bubble 2 and we'll look at how it works. Okay, so it already works here. We don't need to actually change anything to get it to work. Let's just look how it works. Okay, we've got 3 variables that are initialized, declared and initialized. They're global variables up at the top. They're each initialized as 0, and not just because we want them to be number values, but what they're going to do is keep track of how many heads are called, how many tails are called, and what the user, how many total flips the user wants to do. All those are going to start out at either 0 or a get number. So it's not going to break anything to give them an actual value. Okay. And the only other things here are one event handler for the one event, which is the click on the coin, which the coin element here is it's a button. Okay. It looks like an image, and it actually took me a second to figure it out, but you know it's a button because it bounces. All right, let me put this up on the back. There we go. Okay, so you can also, well, if you go into design mode and click on it, it's not clear what element it is because it says text like it's a text element. Okay, like buttons have a text element, but buttons don't, or excuse me, like labels, they don't have a background image situation, and images don't bounce when you click them. But I didn't know this until yesterday, or didn't realize that button elements have a background image property or an image property. So you could set like this, you find an image of a quarter and it's a button now. Okay, so that's just some design, a side note. But the one event handler is when the coin is clicked. When it happens, okay, heads and tails are reset to 0. Now, the first time through, they're already 0, but the second time through, they will have the values of the previous run. And in order for it to be a new run, we need to reset those values. Okay, and then it gets whatever the user has typed in, if they've typed in something, and then it runs our loop. Okay, for those of you new to loops, the only thing that you need to worry about in a loop is that value right there. Okay, the other parts, just basically, it is initializing and declaring a variable named I. That is the traditional variable name for a for loop. Okay, but it's still just a regular variable, which can be named anything. Okay, it's declaring and initializing a counting variable. It's giving a condition to continue the loop so long as that value is less than however many times you want it to do. And then I++ is the same thing as I gets I plus 1. It means that the counting variable increments by 1 every time through. There are rare, but there are examples that are situations where you would want the counting variable to increment by something other than 1, but almost always by 1, and because you're counting how many times the loop happens. Unless you're doing something very specific with the variable, the counting variable, like checking every other item in a list or something like that, then you would want to increment by 2 or something like that, but it's not super necessary. Okay, so like I said, the only value you need to worry about is that one. And in this case, instead of using a hard-coded number, we're using whatever value comes in to the variable from the get number. Okay, and so total flips number of times, it's going to do all of this stuff. Okay, every time through, this local variable flip is it's redeclared. Any local variable, when it runs through, it wipes any previous information, which is going to be relevant shortly. But here, every time through, it picks a random number. And those of you recall, the random number block returns an AppLab, an integer, a whole number between the two numbers you give it, inclusive. So random 0 to 1 is going to return either a 0 or a 1 at approximately 50% chance for each. Okay, this is a great way to come up with something you want to happen 50% of the time. This idea, well, like a coin toss, but any programming situation where you want something to happen 50% of the time, you call a random number 0, 1, and if it's 0, do the one thing, and if it's not 0, in other words, if 1, do the other thing. In this case, it's checking to see if that return is a 0. If it is a 0, heads goes up by 1. Okay, heads plus plus is the same thing as heads gets heads plus 1. Both of these lines of code do the exact same thing with no they are the exact same thing. Okay, each of those makes the variable heads increase by 1. You wouldn't want both of those because you'd increase it by 2. Okay, unfortunately, the math block doesn't have a plus plus thing, which would be nice, but if you do in text mode, it will figure it out like that. Okay, it knows to make it plus plus, but it is what's going on here. Okay, and anytime you see like a local variable used only once, it's probably not necessary. You could do it this way. You could get rid of this and do just if random number 0 to 1 is 0, it's like that. Okay, I don't mind spreading out into another line of code just to sort of keep track of things. That's fine. So after this loop runs, however many times the user asked for, we will have these two variables, heads and tails, will have gone up by the number of times their random number was returned. Then we have a play sound, which you know how I feel about that. And we call update screen. And update screen just sets these two texts. And that's all that's happening. Okay, just some side stuff to think about. Now, having an update screen function is usually a good idea if you're going to make an app where several different things can cause the screen to change. Here, there is only one thing that can cause the screen to change. The update screen function is called only a single time anywhere in the app, which means it's probably not necessary. You could just put these two things and get rid of that, and it would work the exact same. And actually, the same thing would work if you just did all three of these as vars. You could, you don't need to make these changes, but I'm pointing out that because the coin is the only thing that changes things and nothing needs to be persistent, because every time, like I said before, every time you declare a variable, it wipes it. And we are redeclaring the variable every time, the way I have it set up here, every time the thing runs, but it still should work. Let me double check just to make sure. Yeah. Okay. So, I mean, that's one way to think about it. I think the app definitely looks more substantial when you have some actual functions going on, but that's the basic idea. Now, the deliverable is, the reason why it's useful is not super clear, but what they want you to do is change all of these I's to J's. Now, the reason why they're doing it is there are many times in which you would have what's called a nested loop, okay? And that is a loop inside of a loop where you want something to happen several times, and each time that happens, you want something inside of it to happen several times, a specific number of times. But in that case, you need two different counting variables. You can't use var I for both loops. you need something else. And the traditional second variable is J. And I think I've gone up to L. I think I've had a 4 nested loop one time, but like one time. And even the regular 2 nested loop, it's for very specific things like what are called 2-dimensional lists. So this is an important concept. A list can hold anything. It can hold numbers. It can hold strings. Could technically hold a list of Booleans, a list of trues and falses. I've never seen a list of Booleans, but it could happen. It could hold objects, which we haven't talked about it, but it can hold lists. A list can be a list of lists. As in, let's say you have a list with 3 items in it, and each item is a list with 3 items in it. Okay, that can be programmed, or that can be used essentially as a 3x3 grid, where the main list would be considered the columns and each sublist would be a row, and you can access any grid using these 2 counting variables. But we're not going to do that. Okay, and without a visual explanation, it's not super useful, but understanding that you need the same variables for counting, that is important. Okay, so let's go on to bubble 3. Bubble 3 has much more deliverables. So strap in and let's take a look at what happens. So we've got a font tester app. Okay, and it takes a user's input, and as you type, every single keystroke activates something, and it types that whatever text the user is typing in gets set to each one of those 5 different text I guess they're labels probably. And well, we could probably find out. Does it say? I don't know. It's probably a label. Not positive. But either way, it sets them, and each of those spots are already a particular font. Okay. It also has a random phrase feature. It has a font size slider, font color chooser, and like I said, a random phrase generator. Well, I don't know if it's even a generator, a random phrase button that picks one of these 4 strings and sets the text that way. Okay, so let's look at how it works. And it is far more clever than it needs to be. And well, we'll get to it in a second. Okay, so the only variable is the list called phrases, and it is a list of 4 strings. What's in them is not super relevant to explaining how the program works, but they are lists of strings that use several different letters so that, you can see how the different fonts look in using all the letters. I don't think they all use all of them, but either way, they are long strings where you can see letters. And there are 4 different event handlers. The entire program is 4 different event handlers, one for each of the user inputs: the text input, the slider, the color dropdown, and the random phrase button. Each one of those has their own event handler and deals with their own property, and that's why they're all separated. But what's happening here, like I said a second ago, is way more clever than it looks. Please pay attention, those of you who already zoomed out. Thank you. Okay. What's happening is anytime you, let's say, color dropdown, it's a little simpler. Okay. For color dropdown, when you do a dropdown, or, when you do an input, when you change it, what's happening is it's running a loop. And it's running a loop 5 times. And each time through the loop, it's setting the property of the element named text plus I. Now, this is, like I said, super clever, but it's really only specific to AppLab. It's not super useful in regular JavaScript or programming because of the syntax that AppLab uses for setting properties. But this addition, this plus sign, I should say, is not addition. Okay, text plus I, this is concatenation. This is concatenating the word text with the value of I each time through the loop. The value of I changes each time through the loop. Okay, and so that's saying the first time through I is 0, it's saying set the property of text 0. Look at the names of the text elements. They are text 0, text 1, text 2, text 3, text 4. Text 0 through text 4. This only works if you name the elements in this way. But like I said, the first time through I is 0, it's setting the property of text 0, setting its text color to whatever the dropdown is. Then it goes back to the loop. The counting variable goes up by 1. So I is 1 now. And so it's saying set the property of text 1, set its text property to color dropdown. It goes back through the loop. I goes up by 1. Now I is 2. Set the property of text 2, set its text property or text color property that. So each time through, as I increases, it's setting the property of the next one whose name is the word text, followed by whatever the value of I is each time through. Okay. Yeah, it's super clever, but it's only in cases where you want to do like the same thing. Well, I mean, I guess that's the point of a loop if you want to do the same thing a bunch of times, but using the value of I as part of the element ID in the set text is, or set property is fantastic. Okay, so it does the same thing for text input. Every time there is an input in the text input element, okay, the element is called text input, which I am in favor of naming elements with what they are, but naming them exactly what they are could be confusing. I'd probably go with user input or something like that. It is a text input, yes, but it's also named text input, and that's could be confusing. Okay, so text input, when there is an input, meaning any character, which I think we all agree that having things update as you type is better. And by we all agree, I think that, and now you do. So the input, same thing, font slider on change. Although I think font slider is not, okay, so this is the one where it only changes when you release. I don't think that's as good of a event to check for as, is it input? Is input the one that makes a slider work constantly? Yeah, okay, so input is generally the one that changes instantly. The way they have it set up for font slider is just on change, which is only happens when you release it, which is fine. And we just did color dropdown. The one we're going to mess with is the random phrase button. Okay, so how does this work? Well, first, it picks a random phrase. Okay, so there's a new variable, local variable called random phrase, and it is being assigned whatever's in phrases at a random index. Okay, we've done similar things before where we have like var, you don't need to do this yet, I'll tell you when you need to do stuff, but the way we've seen it before is like var rand index. Why does it do that? Var rand index gets a random number that corresponds to a valid index in the phrases list. So we'd go var rand index gets random number between 0 and list.length -1. And then random phrases gets whatever's in phrases at rand index. Okay, so this is picking a random number. Nope, let's go. Did I not copy it, I guess? Yeah, there we go. Okay, so this variable is getting a random number in a range of valid indexes from our list phrases. And then this variable random phrase is getting whatever's in the list at that random number. But again, anytime you have a like single use variable, it's really just there to clean things up, and you might like it better like that. Okay, so we have this variable random phrase is chosen from the list of phrases. And then 5 separate times it's setting the text property of each of the elements, or rather it's setting the property of each of the elements, which there are 5 of them, to that random phrase. Okay, so whatever's in there, you click random phrase, it will give that to you. It also sets the property of the actual input. I don't know if that's super necessary. I would probably just set it to an empty string, but it's fine. Now, the problem is that this list of phrases only has 4 elements in it. That means there is a 25% chance that you get the same thing twice in a row. Okay, we are going to fix that. Now, so this is the part you can follow along. How are we going to fix that? Well, think about just a general algorithm. So in order to keep track, or in order to make sure we don't get the same one twice, we need to keep track of what the last one was. We need to know what the last one is in order to make sure the new one isn't that. So we're going to need a variable. Keeping track should make you think of a variable. So we need a variable, and let's call it old phrase. Why does it do that? Old phrase. But let's see here, old phrase. Let's say we give old phrase random phrase. So we know what the last one was. But think about what's going to happen. We call random phrase, we pick one at random, we give it to old phrase. Next time through, old phrase is redeclared the way it just was with the new random phrase, but redeclaring it wipes any previous knowledge of it. Okay, it wipes that variable. Declaring it wipes that variable, which makes it useless. The only way it's useful is if it's persistent, if it holds what the previous one was, even once the function is run. So it needs to be a global variable. So far, we've only used global variables as a way of making a variable accessible to multiple functions. Okay, but this is a different case where it needs to be global because it needs to be persistent. It can't be wiped. It won't work if it's wiped by the function. Okay, so we're declaring it globally. Random phrase only exists inside of that. It doesn't exist when the app starts. And so we need to give it something. We want it to be a string. Let's just make it an empty string at this point. And that container exists, and now we can use it. Now, how are we going to use it? Well, we need to pick a phrase at random, like it says, and then we need to compare it to the old one. When we compare it to the old one, if they're the same, we want to pick another one at random. So we need to compare. Compare should make you think of conditionals. In this case, we're going to use a while loop. We have not used a while loop yet, I don't think. And the way it's going to work is we're going to check to see if random phrase double equals old phrase, which the first time through, it won't match. Okay, the first time through, old phrase is only an empty string, but every other time it won't be. And what do we want to do if they are the same? If they are the same, we want to re-roll. We want to pick another random phrase. Excuse me. And so how are we going to do that? Well, we'll redeclare random phrase. We'll have random phrase pick another one at random, which the easiest way is just to grab this text because it's everything after the equal sign. And it goes here. Okay. And so we're picking a number at random, or excuse me, picking a phrase at random. We're comparing that new random one to whatever it used to be. If they aren't the same, this gets ignored. Okay. While is, well, the condition is saying keep doing this so long as they're the same. If they are the same, re-roll. Give random phrase a new random one. And when you give it a new random one, come up and check again. If that new random one is the same as the old one, re-roll. Now, the first time through, like I said, they're not going to match, so it's irrelevant, but, or I mean, it's not going to need to re-roll, but we need a way to keep track, no matter if it's the first one or after that, we need a way to keep track of the one that ends up getting selected for this time, so it can be the old phrase next time. So we need to store whatever ends up being selected. So we are going to reassign old phrase, random phrase. Random phrase is the one that ends up getting selected. And if we store the one that ends up getting selected in our old phrase container, it will still be there the next time random phrase button is clicked. Okay. And once we have a random phrase that works, this can go anywhere. No, not that. This doesn't have to go directly after, but I think it makes sense because if we get through this loop, whatever is stored in random phrase is the one we're going with, and we should just go ahead and keep track of it. Okay. So once we get past the loop, random phrase is a useful one. We are keeping track of it, and then we can go about our business like this. With this setup, you will not get a duplicate. And the easiest way to prove this, you don't have to do this, but it's an easy way to prove it, is just make the list 2 items long. If you make it 2 items long, it will very easily show that you're getting the same one twice. And now every click gives us a new one when it catches up. I've got tons of lag here, but okay, every click gives us a new one. And if you had 4, well, a longer list makes it obviously less likely to get a duplicate, but this is still good programming. This is still a good policy of if you want to choose something at random, set it up so they don't get the same one twice. This is different than when we did the add to or make a pair of names from the make a pair of names app. I forget what it's called. That one was picking one at random and then removing it from the list. So the next one that was chosen at random wouldn't get that. Okay. That's accomplishing the same thing, but with the added or the difference of those items are now removed from the list. This situation, we don't want the phrases to be removed from the list. So we don't remove them. We make sure they don't get duplicated by keeping track of the previous one. Okay. And is there something else like we're actually supposed to do here? Play a sound. No, that's pointless. Change a counting variable to a different, it doesn't matter. Add more phrases. Okay. Yeah, don't worry about that stuff. Do the thing that I said. Okay. Text box. Yeah, they're pointing out the text 0 through text box, whatever, which a lot of this is just having you go through and sort of just basically touch the different not syntax parameters of the commands to be familiar and less afraid of them. Okay. And so the only other part of this is a quick check for understanding. And I told you it'd be light lifting today. This will be the extent. Okay. And it is a brief reflection. Okay. Think back to the font tester app from 7 seconds ago. Can you think of an example of another app or feature of an app which would use a loop to control different elements on a screen? Those of you who did the digital scene unit would, I mean, we did loops for that, and there you go. Okay, so that's it. Make sure you're staying on top of due dates and deadlines. It's on you. I'm not going to point it out every class. You know where to get it from the calendar spreadsheet. Okay, let me know if you have any questions. Find something productive to do.